Hello, I hope you're doing great. Welcome to this video. Here I will show my attempt to write a computer program which can play a video game, in this case Moorhuhn. Before I show you if this Moorhuhnbot can actually beat me at the game, I want to talk a little bit about the background of this project. I got the idea when I was reading articles about video games and I stumbled across a discussion about undetectable aimbots, and there was a link to a video from Kamal Carter who built a physical aimbot, meaning he built a robot to physically move his mouse. In his video, he tested the performance of his robot in an aim training software. I highly recommend to watch his video. His work is amazing. Similar to his work, I thought that it would be a fun project to try to write a computer program which uses object detection that can play a video game. The challenge would be that the program at the end has to perform better than I do. I wanted to keep it simple, so instead of building a robot, it will just be a software solution in my case. Since I very much condemn cheating in multiplayer games, and I wanted to do this for a game which I've played myself, I chose a very old and very simple single-player game, Moorhuhn. I am talking about the original Moorhuhn, released in 1999. It is a simple 2D shooter where you have 90 seconds to shoot as many Moorhuhn as possible. The big ones are worth 5 points, the middle ones 10 points and the smallest 25 points. Then there's also the head of a scarecrow and the windmill, which you can also shoot to get points. Occasionally, you hear the sound of a Moorhuhn which is close nearby, which is also worth 25 points. Balloons, planes or signs give negative points if you shoot them. That's basically it. Move around, shoot, reload. Since the Moorhuhn spawn randomly, at least I think so, there's also a lot of luck involved in the game. Let's see what my high score looks like. I'm sure there are people who are better at the game and get better high scores, but for me this is the reference to beat. For the Moorhuhnbot, we need to know where to shoot. One way to do this is object detection. YOLO v5 claims to be one of the fastest object detection algorithms and therefore seems as a good choice. Before we can actually use it for detection, we need to train a model, meaning we need to tell the algorithm what it should detect. Therefore, I wrote a few lines of code which just take a screenshot every second and played a few rounds of the game. Then there is the most tedious part of the whole project, which is labeling. You have to assign a label and bounding box for every target in every screenshot. The documentation of YOLO v5 states that you should have more than 1,500 images per class and over 10,000 instances per class. Contrary to real images, the Moorhuhn always look very similar, so in my case, a smaller number of images and labels should suffice. After labeling, the labeled data is used to train the model, which in my case, since I trained on a CPU, took very long. I'm talking about weeks here. Let's see if the object detection works. This is the graphical user interface of my Moorhuhnbot, which we can also use for testing the object detection. So let's just open a video and see if it can detect anything. The detection itself seems alright, but as you can see, the program is quite slow. We're only getting a few frames per second. To show that this is not due to the model I've trained, here's the output for an example image using YOLO v5's pre-trained model. As you can see, the inference took over 170 milliseconds. Why is that? Didn't I say earlier that YOLO v5 should be very fast? When you look at the x-axis of the graph on the website showing the detection speed, it actually says GPU speed, meaning that the calculations for YOLO v5 were performed on a graphics card. You can also see that the speed for CPU is much slower. Sadly, the PC I'm working on is quite old and does not have an NVIDIA graphics card, which I could use for the detection calculations. Still, I wanted to see how well this bot performs as it is. For now, I've only shown the object detection part. For a working bot, we still need some game logic. In the case of Moorhuhn, my logic is quite simple. The bot works more or less like this. Take a screenshot and see if there are any targets present. If so, shoot at the closest target. If not, move to the left or the right. When at the end of the map, switch directions. If the magazine is empty, reload. After 90 seconds, the game is over and the high score appears. Just press the required buttons to play a new game. I let the bot play a few hours on its own, and this was the high score afterwards. Oh my gosh, the high score is unbelievable! Yeah, it's truly unbelievable. I'm just messing with you. The values here aren't even possible. If I wanted to brag with a good high score, I would do exactly that. Edit the scoreboard and enter the score I want. But this video is not about the best possible high score, it's about writing a good program which plays the game for us. So what high score did the program actually achieve? Nice! The high score of the bot is already better than mine. So I could say, goal achieved, and end the video here. However, there are still 3 points I want to discuss. First, I know that I didn't give a lot of detail on object detection or the code behind the bot. Originally, I planned to make an additional video in which I explain everything in detail, or even make a tutorial. But this would take a lot of time, which I don't really have right now. Furthermore, I don't think that a lot of people will watch this video, and those who do will probably not be very interested in stuff like this. Second, I still want to see how well my bot performs on a system with a proper graphics card. I will show this at the end of the video. And third, I want to talk about cheating. I probably would not have made this video if it wasn't for the articles and videos about aimbots and cheating. I found all kinds of videos about how this new form of cheating could affect computer games, one even claiming that aimbots using machine learning for image recognition could be the end of first-person shooters. Just to clarify a few things here. When you compare cheating software based on object detection to classical cheating software, by which I mean cheating software which tries to use information from the game directly, for example by reading certain values like player positions from memory, object detection has a lot of disadvantages. Remember, you're just looking at the image and you can only get the same information as you could get as a player. You cannot get wall hacks or other invisible information that way. Furthermore, object detection needs computing power, has more delay, and is not 100% accurate. Therefore, well-made classical cheating software will not only perform better, but also provide more information and abilities. The big advantage of cheating software using object detection is that you can set them up in a way that you don't need to install anything on the device the game is running on and make them nearly undetectable. As I have said at the beginning of the video, I condemn cheating in multiplayer games. Nevertheless, I think the discussion about an undetectable aimbot is quite interesting. But how does this actually work? Imagine a simple setup. You are running a program or game on your computer and the graphical output is displayed on a monitor. Now if you like to share your gaming experience live, you could stream the graphical output to a streaming service like Twitch or YouTube. Some popular streamers and competitive players use a dual PC streaming setup. They are playing on their gaming PC, the graphical output is displayed on their gaming monitor and, using a capture card, also transferred to a second PC, which handles the streaming. There are some advantages to this setup. For example, a reduced workload on your gaming PC, which could both increase the graphics quality of your game and of the stream. But what if we use the second PC for something else? What if we want to use it for cheating? The game itself runs on the gaming PC. Most anti-cheat software checks this PC for cheat programs. There is no way for anti-cheat software on the gaming PC to check what the second PC does. So we could, for example, safely do object detection on the second PC. The only thing left to do is to transmit the calculated mouse movement or keystrokes to the gaming PC. One way to do this was shown at the beginning of the video, by moving the mouse of the gaming PC using a robot like Kamal Carter did. In this setup, the gaming PC is absolutely clean. Anti-cheat software cannot find any cheating software because there simply isn't any on the gaming system. The only way to detect cheating in this case would be if an algorithm can tell if the mouse is moved in a way a human would move it or not. But that cannot be done with 100% accuracy. or in other words, without risking to ban legit players as well. There is something else I wanted to play around with, and this is a good opportunity. Let's go back to our simple gaming setup. To play or work on a computer, we use a keyboard and mouse. They can either be wired to the computer or transmit wireless signals. In most of the cases, you just plug the wireless receiver in a USB port of the computer and you can use your wireless mouse and keyboard. But what if, instead of a mouse and keyboard, the signals are sent from a different device? As long as the signals are the same, there is no way for the receiver to tell which device is sending the signals. I read about vulnerabilities in wireless mice and keyboards, so I wanted to try it out. See if I could send commands to a receiver, moving the mouse or pressing some keys. Bastille's research discovered vulnerabilities in some wireless mice and keyboards, allowing for different kinds of attacks. For example, keystroke injection. If somebody near you is using a vulnerable wireless mouse, you could send keystrokes or mouse movements or clicking commands, which would be executed on their machine. In theory, this could be used for malicious attacks, which of course I won't be doing. I just want to see if I can use this to play Moorhuhn on a different PC. As shown before, my setup looks like this. I used the receiver of a keyboard of a well-known brand, which also has a touchpad. Therefore, it is plausible to receive both keystrokes and mouse movement commands on this device. In my case, I will send these commands from the second PC using an antenna. I wrote a little program for testing this setup. It displays the video from the capture card, can be used to search for vulnerable devices, and allows for keystrokes, mouse movement and mouse clicks to be sent to the USB receiver. Here I just sent the player name and confirm this by sending enter. Then I show that the commands for clicking and mouse movement are actually working. Just in case you're wondering about the FPS counter. The capture card I'm using can only transmit 30 frames per second, that's why the FPS counter is always close to 30. As you might have noticed, the commands sent using keystroke injection have a bit of delay. Since I aim for good performance and I don't want to spend a lot of time optimizing this part of the code, I won't use it to play the game. It was still fun to play around with, though. Speaking of performance, let's run the object detection on the graphics card and see how the program performs. Therefore, I switched to a different setup. Not bad. Let's see what the high score looks like. To be honest, I'm underwhelmed. I expected more. In comparison, it is just barely better than the high score which I got when I ran the image detection on the CPU. Why is that? When looking at the gameplay, I'm very happy with the result. Just from looking at it, I can already tell that the program runs faster on this setup. I let the program play over 700 games. The average frames per second for each game were above 60 FPS, which made me very happy. What I noticed is that the movements seemed to be slower on the new setup. And indeed, when moving from one side of the map to the other, there's quite a difference between the two setups. I'm not sure why this is the case, I just have some theories. In this movement test, the bot is not active. It is just playing the game on two different computers with different hardware. If we assume that the Moorhuhn spawn randomly across the map, it is evident that a slower movement speed results in lesser points. Therefore, these two scores are not comparable. You might have noticed the option Ignore Windmill in my program. I added this because when running object detection on the CPU, the program was actually too slow to hit the Moorhuhn on the windmill. Let's take a closer look how the bot works. First, the program takes a screenshot. Then it looks at the image and detects all targets in it. Now it selects a target, usually the one closest to the mouse position, and tries to shoot it. However, object detection takes time. So in this few milliseconds the Moorhuhn have moved a bit, and the shot might miss. I was curious if the program would now be fast enough to hit these targets as well. As you will see in the video afterwards, it's on the edge, but finally manages it. There is another thing regarding the windmill. Nearly all Moorhuhner change their appearance when shot, but not the ones on the windmill. Therefore, in the training data, I also marked them as targets, even if they are not attached to the windmill anymore, to keep the labels for the object detection consistent. If I just wanted to get a good score, I would simply tell the program to shoot at the center of the windmill. This hits all targets, and there is no time wasted. It's quite easy to code as well. Here you can see it in action. But this feels a bit like cheating, and again, I wanted to see if the bot manages to hit the shots and how it is working out. For the clip of the game, I chose a recording where the bot actually has some difficulties to hit the Moorhuhner on the windmill when rotating, and then continues to chase them after they are shot down. I think this is quite interesting to see. I am nearly at the end of my video. I hope you liked it. Thank you very much for watching. Here is a full unedited game of Moorhuhn, played by my Moorhuhnbot. With that, I wish you a fantastic day. Goodbye.